Hey everyone, welcome. We are talking permutations, combinations, and we're going to talk a little bit of probability today. The big ticket item that you need to know is permutation, order matters. So it's all about placement. Combination, order does not matter. So if I have like a committee, that's a big keyword, committee, um, or things that I'm choosing where order just doesn't particularly mean much. And then the last thing you need to know with these notes is probability means percent. So with probability, you're going to have some type of fraction that's going to give you some type of percent. Okay. So let's talk a little bit about permutation. As I said before, permutation order matters. It's by making a list. A lot of times it's batting order. Like if you have sports, it's a batting order. If you're electing officers, president, vice president, secretary, treasurer, things that you can't replace. So once somebody is your president, nobody else can be president. Like that person can't be anything else. Then you kind of move on. That's a permutation. Combination, on the other hand, okay, I'm going to skip factorial for a second. Combination, on the other hand, is like you're choosing people from a committee. You're picking people for a team. It's a lot different than batting order. Batting order matters. Once somebody goes in the batting order, they can't go again. Combination, if you're choosing people for a team, it doesn't matter who you choose. You just need so many people. It's when order just does not matter. Okay. And both of these, if you look, you see that there's two different formulas, and you see this exclamation point. The exclamation point in mathematics means factorial. So the way that a factorial works is it's a shorthand way of multiplying every number that precedes the number of the factorial. So for example, in this one, 5 factorial means 5 times 4 times 3 times 2 times 1. If it was 3 factorial, it would be 3 times 2 times 1. If it was 7 factorial, it's 7 times 6 times 5 times 2, 5 times 4 times 3 times 2 times 1, and so forth. Okay, so it's just multiplying, going down basically. On your calculator, you can find these. I'm going to show you how to in this video as well. Permutation versus combination. I'm going to read each of these next 3 examples, and in your head, I'm going to give you a pause. I want you to think, does order matter or does order not matter? Because that's going to determine whether you're using a combination or a permutation. How many ways are there to give 3 honorable mention awards to a group of 8 entrants in a contest? Permutation, combination, combination. Order does not matter. If they said how many ways to give a first, second, and third prize, boom, permutation. But because they're all getting the same award, and it doesn't matter who out of the 8 were picked, it's going to be a combination. So we're going to write this as 8, and we're choosing 3. Okay. Just a little side note, the bigger number will always go on the left. And now let's take a look at how to plug this into your calculator. Now, some of you are going to have calculators that are going to be a little bit different than mine. Either way, you're going to go into your math button, and it's either going to say PRB or PROB. And since this is a combination, if you notice, there's permutation, combinations, and factorials. You're going to want to go to combinations. So again, math, PROB or PRB, and then your combination. Now, some of you with the older calculators will have to type in the 8 first and then go to this page. Others of you that have the newer calculators like I do, it'll let you fill in the 8 and the 3 and then hit enter. It does that formula that it showed on your notes page. It does everything for you to get your result. What I'm going to ask whenever you're taking your exam is going to be very similar to what you're plugging into your calculator, since it's just a graded assignment. Okay. So I'm just going to ask you mainly, what did you plug in? So 8C3 is going to give you 56. So there are 56 ways to choose. Again, math, go to probability. And again, some of you might have the older TI-83 or 84, so you'll have to put in 8 and then go math, NCR, NBR, and then your other number and hit enter. All right, example number 2. How many ways are there to award first prize, second prize, and third prize to a group of 8 entrants in a contest? Combination of permutation. Permutation order does matter. So in this case, NPR, which is going to be N or 8P3, 8 permutated 3 ways. So go back into your calculators. Okay, I'll show you here. Going to go into math. 8, 3, and 336 ways. All right, last example here. How many ways can 9 players be selected from a team of 15 to start the softball game? Permutation or combination? If you said combination, you are correct. If this was saying how many lineups can we make, then it'd be different because you're choosing somebody to go first, second, and third. Because it just wants 9 people from 15, kind of like a Sandlot game. This is going to be a combination. So 15, choose 9. So plug that into your calculators. Just have a side calculator. I don't know what happened. Math. And 5,005 ways. All right. Questions, permutation combinations, just them specifically. And notice it says number of ways. Okay, so we'll have a number. When it's probability, it's a little different, which we'll get to here in a few minutes. Okay, so here's some factorial stuff. Just real quick, factorials, when they're super big, make an overflow in your calculator. So if you were to plug in 100 factorial into your calculator, I'm going to show you this one, and then I'll stop going back and forth. So I'm going to hit 100, and then I'm going to go back into math. I'm going to type in my exclamation point, hit enter, overflow, because it's 100 times 99 times 98 times 97 times 96 and so forth. Like, it's too big of a number. So when you have things like that and you have multiple that you're trying to go through and you're dividing, you're going to want to simplify before you actually plug them in. So like I said before, 100 factorial, that's 100 times 99 times 98 times 97, ... And then it goes to 2 times 1. 98 then is 98 times 97 times 96, ... 2 times 1. You can start canceling things out until you get to what you have left. Okay. So if you take 100 factorial and plug it into a calculator, it's going to give you an overflow. You have to simplify these before you actually plug them into a calculator, because otherwise it won't work. If you plug in 100 factorial divided by 98 factorial, it's going to give you an overflow still in your calculator. There's not really a workaround that I personally know. I know some of you are a little bit smarter than me. You'll find one. But it's mainly just you simplify it as you go. If you look at example 5 here, you've got 95 factorial and then 3 factorial, 97 factorial. That's the same as saying like 95, 94, 93. You're multiplying until you get down. 3 factorial is just 3 times 2 times 1. And then you've got 97, 96, 95. And notice, as soon as I hit 95, I have 95 up top. Everything below that is going to scratch out. So now I have 1 over 6 times 97 times 96. I don't know what that is off the top of my head. Got a calculator on the side here. So 1 over 55,872. If you make this into a decimal, it would be 0.0000018. I'm going to pause for a second there. Permutations, combinations, factorials. Questions at all? So we're going to get into probability. Probability is a little more. Yep.
Why wouldn't 3, 2, 1 cancel out?
There's 2 3 2 1s in it. So think of the 3 factorial has a 3 2 1, and then the 97 factorial at the very end will also have a 3 2 1. So you have 2 of them on your bottom.
Oh, and that's not the same as 1 on top.
Correct. Yeah. Since you only have 1, you can only cancel out the 1 on each.
Okay.
All right. Probability. So probability is a little more tricky, especially whenever it comes to combinations, which is the main thing that you see in these. As I said before, probability means percent. So your answer for probability will be a percent, which means that you'll have some type of fraction. Probability is the number of favorable outcomes over the total number of outcomes. It's mainly called theoretical probability, but because it's a percent, it's got to be from 0 to 1. Okay. So like 1 to 0 to 100% for the most part. So take a look at example 6. If one card is drawn from a standard deck of 52 playing cards, what is the probability of getting a diamond? So the first thing that we need to know is how many diamonds we actually have in a set of 52. So one card is drawn from a standard deck of 52. Probability of getting a diamond, there are 13 diamonds out of 52 cards. So that would be 1/4 or 25%. If you don't know cards, let me know. Does anybody need help in this area? There's hearts, clubs, spades, diamonds, 4 suits, 13 cards, the kings and queens and all that kind of stuff. They repeat 4 times. We can go over a little more extensive after the video if needed. Multiplication counting principle. Okay, so if there are m ways to make a first selection, n ways to make the second, there are m times n ways to make the 2 selections. This is one of those weird random ones that is just kind of thrown in here because you'll probably see it on like an SAT. But essentially, a math quiz has 10 multiple choice questions on it. Each have 4 possible answers. How many different ways can all 10 questions be answered? So think of it as your first question has 4 choices. Your next one has 4 choices, 4 choices, 4 choices, 4 choices, 4 choices, 4 choices, and so forth. There's an easier way. If you notice, I've got 1, 2, 3, 4, 5, and I'll end up with 10 different types. So 4 to the 10th power will get me my solution. Again, this is this multiplication counting principle is just a weird one. I'm going to be completely honest with you guys. The only time that you really see it is like multiple choice type questions. It'll stand right out as soon as you're able to see it on your exam, because it'll be one of those ones where you're like, I can't use permutations, I can't use combinations. It's not a probability. What is it? And then if you have a question at all, you can always just kind of ask me. But if you have 4 possible, how many ways can all 10 questions be answered? 1,040,000 40 48,576 ways. You can write it out if you want to, but it's going to be a little bit easier to do to an exponential. It's 4 to the 10th power. Number 8 is very similar with the counting principle. It's just a different way to look at how to use multiplication to solve. So license plate consists of 2 letters followed by 3 digits. The letters A and Z and the numbers 0 through 9 can be repeated. So think of it, we have A to Z, we have 26. 0 to 9, we have 10. So find the probability, okay, there's a key word there, probability means fraction, that your new license plate contains the initials of your first and last name and the first 3 digits of your phone number in their proper order. So first off, your new license plate's initials of your first and last name. So my first name only has 1 letter, 1 initial out of 26. My last name only has 1 out of 26. The first 3 digits of my phone number in the proper order, I've only got 1 out of 10 numbers, 1 out of 10 numbers, and 1 out of 10 numbers. So notice how we've taken those specific ones. So there's like a 1 out of whatever that big number is down below chance that you're going to get that type of situation. So 676,000 chance, which equates to a 0.0000014, which is a 0.00014% chance of this occurring. Because you'll move your decimal twice. That you'll have your first and last name initials and your phone number in their proper order for your zip code. Yep. Because I need each specific one has a space. So the first one has a 1 out of 26 chance of getting just that one initial. And then the next one would have a 1 out of 26 chance of getting that specific initial too. So they have to be separate from each other. Just like the last 3, there's 3 different chances for me to get 3 different. It's a specific spot. So the first number has to correspond with the first number of my phone number, the first digit of my phone number. Then the next one has to correspond with the second. So there's only a 1 out of 10 chance there, and then so forth for that too. All right, and then the last one here, that's a little random and kind of wonky. Out of 300, if 350 out of 795 people share an opinion, what's the probability that one person shares this opinion? If 350 share the opinion, then there's a chance that if I pick one of them out of the 795, that they will also share the opinion. So 350 divided by 795. So there's a 44% chance that someone is going to share the same opinion. I don't know what that opinion is. Maybe it's Marvel movies are awesome or something. Everybody's like, hopefully that would be 100%, but I don't know. There's some crazy stuff going on out there. All right. Last thing that I have for you is probably the most difficult. Permutation and combinations with probability. So this is using, usually it's combinations. think this first one might be a permutation, but let's kind of dig into it. You and your friends are auditioning for a part in a school play. There are 15 people auditioning, and the order of the auditions is chosen at random. Find the probability that your audition is last and your friend's audition is second to last. Okay, so there are 15 people auditioning. So that means that there are 15 people to start. The order of the audition is chosen at random. So once one person is selected, they're not selected anymore. Find the probability that your friend's audition is that yours is last and your friend's audition is second to last. So you know that your friend has to be here. Let me write all this out real quick because this one is tripping up me a little bit, to be honest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I have 15 people to choose from out of 15 for my first part. Then I have 14 out of 14 to choose from, and 13 out of 13 to choose from, and 12 out of 12 to choose from. I'm not going to lie, guys. For some reason, I'm drawing a blank on this one. I'm thinking I'm going to skip it and go to number 11. Yeah, so I mean, this is what I would possibly say is that I have 15 permutated 13 times because there's 13 other people. Yeah, so that's like a specific place. I gotta stew on this one a little bit. So 15P1 and then 15P1. I don't know. You know what? For this video, I'm completely honest. I'm gonna get back to you on it. Okay. Sorry about that. We'll talk about that one tomorrow. Let's take a look at number 11. If I figure it out, I'll let you guys know. But it's been a little bit since I've seen that one, and unfortunately I'm not all knowing. Example 11 though, this one I do remember. Suppose 4 light bulbs are chosen at random without replacement from a box of 12 light bulbs, 4 of which are defective. Find the probability of selecting all effective light bulbs, 1 defective light bulb, and all defective. So the way that this works is if I have 4 light bulbs that are chosen at random from a box of 12. So I first off, probability. I have 12 things. I'm choosing 4. And letter A, I want to find out if they're all effective bulbs. Well, if I have 4, so it says 4 defective. That means that I also have 8 non-defective, I guess, or effective. That's my effective. So if all are effective, I have 8, and I'm choosing 4. So what I'm going to do in my calculator is I'm just going to type in those 2 things. So 8, choose 4. So 70 over 12, choose 4. So 495. So the probability of selecting all 4 that are effective is going to be about 14.1%. So there it says that find the probability of selecting all effective bulbs. So it tells us that we have 12 light bulbs. 8 work, 4 don't work. That's basically it. So 8 choosing 4 because we want all 4 of them to work. In letter B, we want one defective. So if I have 4 that are defective, I'm choosing 1. But I also have to choose 3 other light bulbs. So those other light bulbs have to be from the 8 non-defective, and I'm choosing 3 over 12, choose 4. So now I've got to multiply those together. So I'm back to plugging things into my calculator. 4 choose 1. So 4 times 8 choose 3. So 4 times 56 divided by 495 is going to give me 0.4525. So 45.3%. There is a chance that I'm going to grab some light bulbs, grab 4 of them, and one of them's not going to work. So letter C. What happens if they're all defective? Well, then I've got 4. I'm choosing 4, hoping that they all don't work. I don't know why I would do that. And then 12, choose 4. So let's plug that in. So 4, choose 4 is 1. So 1 over 495, which is going to give me 0.2%.